Good afternoon. It is January 2nd, northern Wisconsin, brisk winter day. Not too bad. I think it's about 21 degrees. Finally got a little bit of white stuff on the ground here. Got some more work done in here. I got the DC 48 volt to 12 volt step down installed and running, and that powers light, a little night light, and 12 volt receptacles, and also runs to that switch which powers up the heated floor to keep the batteries from hard freezing. Again, sorry if I'm shaking a little bit. I've been out here all day and I'm a little chilly. So, floor is warming, and that's using about 35-40 watts. Solar made some juice today finally. Oh, and it just reset itself. Well, it made about 4 kilowatt hours. I think the timer, the clock is not set on that, so it reset, but it was just making over 1,000 watts. Actually, it was making 1,050 watts about an hour ago when the sun was out. So that's awesome. We're getting 100% and better percent of rated power out of our panels. The inverter is working real good. We did a few load tests on that, ran the well for a little while, ran a space heater all day off of our outlet here. I just set it up over here and, tried to keep myself from freezing too hard. Made a little mini bus bar for the DC loads, and then also made a switching system for the wind with knife blades. So in the down position, it's going through the fuses up to the charge controller, so it's charging. You can see they're just barely spinning. This is probably nothing for wind, 4 or 5 miles an hour, and it's actually making power. This controller is so awesome. I'm getting one of these from my house soon. So we put that in the outward position, and now it's open. There's no power going to the controller, and you can see it sped up a little bit. That's freewheeling, and that's just there in case we have to service or disconnect the charge controller. You never want incoming power going to your charge controllers when you are not connected to a battery. And then in the upward position, that applies the brakes. There's a piece of copper soldered to the top, and it didn't quite slow her down yet, but it will slowly. It's just an electromagnetic brake. It'll slowly bring her down to a standstill, and she's charging again. Cool, huh? So, but, and then, yeah, we got our battery temp sensor for the solar charge controller, and the remote voltage sense runs straight to the battery bank. That helps the battery know what actual state of charge is, because with lower end, smaller charge controllers that just have, 2 wires going straight to the battery, it's applying power and sometimes it gets a not as accurate voltage read. So, you know, you send a small, real thin wire straight to the bank, and it gets as accurate as possible of state of charge reading, so it knows exactly how to safely charge the batteries. And I've got my diversion load put together. I'm going to run 3 1 ohm 100 watt ceramic resistors in series for a 300 watt diversion load. The dump load controller is still on the way. Shipping got a little behind on that, but no worries. This does mitigate over voltage pretty well. It has an internal dump load, but I don't want that, you know, to be the permanent solution. I don't want it warming that case up. I would rather warm up that, you know, that's built to warm up on metal plates, so it'll never overheat. I don't like my controllers getting too hot, so we're gonna run a dump load and set the voltage for, you know, 60.5, and then it'll begin to dump into the resistors, and it'll siphon off 300 watts right away. And as they warm up, they get more resistive, so it'll, if there's that much power coming in, it'll continue to draw more power. So that's that. Panels are all looking nice and pretty. Birds flying nice and pretty. We did not dig our trench for the power cable going over to the panel, but I'll show you that real quick. Alright, so this is the well. This is an older well, 240 volt well. I think it uses about 11 amps, so it's a good deal of juice required to run it. Did not hardwire that yet into our box, but there we go. But there eventually will be a building right here. So we've got 240 and 110 with our breakers run out here. So when construction of the building begins, we've got power. They don't need to run a generator to run power tools and get water or anything. So this will all eventually be covered up with a building. I think he plans on cornering it out right here, taking a few trees down. But so that's this right here is the primary reason we built this power plant. And you know, I said, well, since we're going to build a power plant, we may as well build it sufficient enough to be able to run some tools also. So that's why we went with the size inverter we did. We needed the split phase to run the 240 volt, and then tapped off of that so we can, you know, run some 110 power tools. And when the cabin is built, this will power the cabin, and he'll never have to call a utility company and pay $10,000 to have them run a line and a meter out. and never have a bill. So there's that. So I'm starting to get cold, so I'm going to wrap this up, but I did want to just, talk quickly about this inverter. These are very capable inverters. They're designed for running a house, basically. You can wire this straight into your main panel, and this can be set up a bunch of different ways. It's got a built-in charger. It can be set for battery priority if you wanted this in your house, for backup power. It could be set to grid priority, where you tie it to the grid, and it charges and floats the batteries, keeps them ready if the grid goes down. This powers up the line so fast that you don't even know there was a power interruption, and when the grid comes back, it'll switch back to grid power and recharge the batteries. It also has a generator start function where if you were off grid and your batteries ran low and there was no charging sources, no sun, no wind, it could start a generator, and with the built-in charger, recharge the batteries, pass through the power from the generator to run all the outlets. Also, never having a power interruption, and when the batteries are safe to run on their own, it can shut down the generator, or it can just run standalone off grid like this. This has got no shore power, no generators hooked up to it, just the solar and the wind. Or you could put this in your house if you wanted to massively offset power. You could set it for battery priority, where it's going to run off the batteries as much as it can, and if the batteries run low, it'll then take the shore power, recharge, and switch back to the batteries when it's safe. So very, very impressed with it so far. I did a couple load tests. I forgot to bring my tripod, so I didn't get any of that on film. I'm not done here. I want to get the diversion load completed and finish tidying up, build a battery box, invent that, and then I'll do a more exciting video of it, running my brick saw. I'll bring some bricks and different stuff. I can bring my welder out here and run some big loads and show you what it can do. But essentially, because it's a split phase, it's essentially two 2,000 watt inverters sync together in parallel, so the sine waves run together. Yeah, good product. And yeah, I think that's all I got for now. So thanks for watching. Safe out there. Happy New Year's. Hope everyone had a Merry Christmas. And take care and God bless.